Hi, this is Alfausia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in today's video is the continuation of the previous video. The last video is arcs and chords. This is the second part of arcs and chords. We are going to see the application of theorems under arcs and chords in the problem. Okay, let us start with today's session. Let me post the theorem first. Theorem states that in a circle, if two minor arcs are equal in measure, then the corresponding chords are equal in measure. Okay, let me give you one example and see how it applies. Here is the example. Please look at this figure. Using this figure, you have to determine measure of the CD and GH. Under the given conditions, AB equal to CD, measure of the arc AB equal to 60 degrees, measure of the arc EF equal to GH, and EF equal to 8. We are going to apply two theorems in this example. Okay, this figure explains you the relationship between equality of the measures of chords and equality of measures of their corresponding minor arcs. Please note that the chords I mean here is a non-diameter chord. Okay, the chord that passes through the center would be known as diameter, but I'm not talking about that chord. Except the diameter, you have to consider the other chords. So you have to look at the relationship between the equality of the measure of the chords and equality of the measure of their corresponding minor arcs. Okay, from the theorem, we know that in a circle, if two chords are equal in measure, then the corresponding minor arcs are equal in measure. So it is given that AB equal to CD. So if the arc AB equal to 60 degree, then the arc CD will also be equal to 60 degrees. Am I right? Plug in arc AB equal to 60 degree. Switch the sides. Hope you are clear till this step. Okay, now let us move on to part B. It is given that measure of arc EF is equal to measure of the arc GH and EF equal to 8. Now let's find what is GH. This is nothing but the converse of the first theorem. If two minor arcs are equal in measure, then the corresponding chords are equal in measure. So let us see what is given in part B. Therefore, the chords are equal. So what is the given value for EF? 8. Swap the sides. That's it for this example. Hope you are clear with this example. Okay, in this example you will learn two of the theorems and its application. Let me show some more additional theorems about chords in a circle. Okay, these theorems can be used to solve many types of problems. Okay, I'll just state the theorem first. Here is the next theorem. If a diameter is perpendicular to a chord, then it bisects the chord and its arcs. So it equally divides the chords and equally divides the arcs. Okay, so UT is the diameter, QS is the chord. UT is perpendicular to QS. So obviously it will make 90 degrees. Okay. So the chord is bisected. It means QR is equal to RS. This theorem says it also bisects its arc. So arc for QR is QT and arc for RS is ST. Does this make sense to you so far? Same way, there is one more pair is there. Please look at this. It divides the arc QU and US. So the arcs will also be bisected. It means QU, the measure of the arc QU, will be equal to measure of the arc SU. Hope you are clear with this concept. Okay, now let me post the next theorem. In a circle, if two chords are equal in measure, then they are equidistant from the center. Please see the figure. There are two chords AB and CD. O is the center. Let X be the point where the center meets the chord AB and Y be the point where the center O meets the chord CD. In case if the two chords are equal in measure, if AB is equal to CD, then by the theorem, in a circle, if two chords are equal in measure, then they are equidistant from the center. So what is the distance between AB and the center? OX. And what is the distance between center and CD chord? OY. So the distances will be equal. OX will be equal to OY. So this is a circle which shows the relationship between two chords being equal in measure and being equidistant from the center. Hope you're clear with this theorem. Here is the next theorem. Please see, in a circle, if two chords are equidistant from the center of the circle, it means imagine two chords and imagine that they are equidistant from the center of the circle. Then obviously the two chords will be equal. This is just the converse of the previous theorem. Let me show how to apply this theorem in an example. Please look at this figure. AB and CD are two chords. O is the center and XY are the points where the center meets the two chords. So it says that if two chords are equidistant from the center of the circle, it means if OX is equal to OY. So then by this theorem you can say that the two chords are equal in measure. AB will be equal to CD. This is the meaning of this theorem. Now let me take one example. Do you see this example? A circle with two chords are given. Please note that the measurement for the two chords are given 8, 8. So these two are equal. To avoid confusion, let me name the chords. If the two chords are equal in length, their minor arcs will also be equal. So the arc AB is equal to 40 degree will be equal to the arc CD. This is the given information. So the minor arcs will also be equal. Where AB is 40 degree, just swap the sides. That's it for this example. Hope you're clear with this example. So this is just a circle with two minor arcs equal in measure. Please look at this example. In this figure, the measure of the arc AC will be equal to 115 and measure of the arc BD will be equal to 115. It is given that BD equal to 10. So first let us take down all the given information. From the given information, you can say that the arcs AC will be equal to arc BD. So these two arcs are equal. If the two minor arcs are equal in measure, then their chords will also be equal. Am I right? So what are the two chords on the figure? Where PD is 10. Therefore AC will also be equal to 10. Hence the example. Hope you're clear with this example. You have to know the reason behind each and every step. So first you have to note down all the given information. From the given information you will get some clue, or if you want any other clue, the important information will be given separately. So you should know how to use the given information and move towards the answer. So this figure means a circle with two minor arcs equal in measure. Hope you're clear with this example. Here is the next example. You have to use the figure in which AB equal to 10, OA equal to 13 and measure of the angle AOB is 55. To find OM, so we are supposed to find the three things here. OM, measure of the arc AT and measure of the arc SB. Okay, let me draw the figure for you. In this figure, ST is the diameter, AB is the chord, OA and OB are the two radius, and diameter is perpendicular to the chord. So here is a symbol mentioning that. Okay, a circle with a diameter perpendicular to the chord. By looking at the figure, we can say that ST is perpendicular to AB and ST is a diameter. For the problems with the theorem application in arcs and chords, you have to look at the given figure carefully. In case if the given information is not clear in the question statement, you can look at the figure to take the more information. Okay, let's see what theorem is applicable here. Hope you remember this theorem. If a diameter is perpendicular to a chord, then it bisects the chord and its arcs. So it means AM is equal to BM. It bisects means two equal halves. AB is divided into two equal pieces, AM and BM, and the pieces will be equal. It is given that AB equal to 10, so BM will also be equal to 10. Am I right? AB is the entire chord. If it is equal to 10, half of 10 will be equal to 5. Now consider the right triangle AMO. Since OA, it is given that equal to 13 and we found that AM equal to 5 because AM is nothing but the half of AB. So OA equal to 13, AM equal to 5. So OM can be found by using Pythagoras theorem also. Let me show you on the board. Pythagoras theorem says hypotenuse the whole square will be equal to the squares of the sum of the other two sides. Just plug in the given information. Replace AM by 5 and OA by 13. Square of 5 is 25, square of 13 is 169. Subtract 25 from both these sides. take square root. Hope you're clear so far. The same theorem says that measure of the arc AT equal to measure of the arc TB and measure of the arc AS equal to measure of the arc SB. Since measure of the angle AOB is equal to 55 degrees, this is given in the question itself, that would make measure of the arc AB equal to 55 degrees. If this arc is 55, what would be the rest of the arc? The circle would be 360 degrees. So just subtract 55 from 360. Actually, we are asked to find the measure of the arc AT. Measure of the arc AT is nothing but half the measure of the arc AB. Where AB is 55, half of 55 is 27.5 or 27.5. Hope you are clear so far. Same way, let's find what is the measure of the arc SB. Measure of the arc SB is nothing but half the measure of the arc ASB. ASB is 305. So what is half of 305? That's it for this example. Hope you are clear with the application of all the theorems in the example. Once you learn the basic meaning, it will be easy for you to apply it in the theorem. In the example, you have to take down all the given information and look for the clue. And once you see the given information, you can understand which theorem will be applicable. So you should know the meaning, inner meaning of each and every theorem. Okay, hope you're clear with this session. See you in the next video. Have a great time ahead.